Hi, I'm going to go over problem number 4. In this problem, okay, our source is going to be 5. I'm going to make a chart for us to keep track of our nodes and values. So our nodes, we have 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Maybe I could not. Okay. And then we're going to do the shortest distance and the parent. Let me erase this. Okay. So let's go to 5. 5's, let me see, hold on. Five's shortest distance is 0 because it is the source and the parent is nil. And then 5 points to 1 and 9. The distance between 5 to 1 is 1 right here. That's the 1 value. So we can put 1 here, and the parent's going to be 5. And then it also points to 9 with a distance of 1. So we do 1 here and a parent of 5. Okay, so now that we've fully discovered 5, we can check that off. Now from top to bottom, we look for the node with the shortest distance. So 1 has a distance of 1, and the only other one we have is 9 with a distance of 1. So because we're going from top to bottom here, we're going to go with 1. So let's go into 1. And it only points at 2 with a distance of 1, but we have to add whatever value we have here for 1. So we're adding 1. So the distance from 5 to 2 would be 2, and the parent would be 1. And then we could check off 1 because we fully discovered it. And now from top to bottom again, we look for the shortest value. So we have node 2 with a distance of 2, and we have node 9 with a distance of 1. So we're going to go with 9. And 9 points to 10. So when you add 1, you add the value that's in here. Oh, also, I forgot. For part A, asks for the order in which the vertices are extracted. So first we went to 5, then we went to 1, and then we went to 9. Okay, and sorry, back to where we were here. We are looking into 9, and it points to 10, and we add the value we have right here, and that becomes 2. So for 10, we can put 2, and the parent's going to be 9. And now we can check off 9 because that's been fully discovered. Okay, so next we can go back to our list from top to bottom. The shortest distance that we have from top to bottom, let's see, we have node 2 with the distance of 2, and we have node 10 with the distance of 2. But we're going to go with node 2 because we're going from top to bottom. And node 2 is over here. I'm going to write down 2. Okay. Node 2 points to 5, 6, 7, and 3. So, let's see. I'm going to put plus 2 because that's the value in our chart. Plus 2 to everything that's pointing at. So for 5, it's 2 plus 2, which is 4. But because 4 is a bigger distance than what we already have, which is 0, we're not going to update it. And then we have 2 pointing to 6. Distance is 5. So at 6 we could put 5 with a parent of 2. And then 2 pointing to 7. Distance is 3. And parent is 2. And then 2 pointing to 3. Distance is 4. So at 3 we could put 4. Parent of 2. Okay, so now we can check off number 2, or node 2, because we fully discovered it. Now we go through our list again, top to bottom. The shortest distance node we can look at right now would be 10, with a distance of 2. So let's go to 10. I'm going to write this down here. Oh, sorry. 10. Okay. 10 is pointing at 6 plus 2, and 10 is pointing at 7 plus 2. So from 10 pointing to 6 would be the length of 3, which is shorter than the 5 we have right now in our list right here. So we can update this to 3 with a parent of 10 instead. And then it also points at 7 with a distance of 5, which is bigger than what we have right now for 7, so we're not going to update it. And now we can check off 10. Okay, time to look at our list again, top to bottom. The shortest value that I see would be 6, because we're going top to bottom. We're going to do 6 first instead of 7. So we go to 6. 6 points to 9, and 6 has the length of 3, so that's 5. But 9 already has a value of 1, which is less than 5, so we are going to leave it alone, and we are done with 6. So now we go again top to bottom. Smallest one we have is 7, so let's go into 7. And 7 has a 3, points at 8, so 8 is going to be 4, and the parent is going to be 7. And we can check off 7. Top to bottom, we're going to go into 3. So 3, and it has a distance of 4, and it points to 7 as well. But because the distance is 5 for 7, which is greater than what we already have right here, we're going to leave it alone. And from 3 to 4, it's 6, and parent is 3. And we are done with looking into 3. Now, from top to bottom, we only have node 4 and 8 left, but 8 has a shorter distance of 4, so we're going to go into 8. And 8 has a distance of 4, and it points to 4, so that's 7, which is not less than 6 that we already have for 4. So we're going to leave alone, and we're done with 8. And the last one we go into is 4, doesn't point to anything, and we are done with this. Let me just double check my work. So 51921067384, perfect. And then for part B, it's literally what we wrote here. So dx is the distance, which is 1, and px is the parent. So 152.630.0.310.3.2.4.7.1.5 and 2.9. Let me double check my work. 152.142.630.0.310. 1.5 and then 2.9. Okay, yep. So this is how you do problem number 4.